All right, chapter 5, lesson 7, last lesson in this chapter. It talks about yet another formula, another use of Pythagorean theorem. So let's first talk about the use of the Pythagorean theorem part of it, and then I will introduce the formula to you, and you can see how one goes with the other, and then you can make your preference. So first of all, let's talk about Pythagorean theorem, and if you remember, a squared plus b squared equals c squared. These two were your legs. This one was the hypotenuse, and that only works with a right triangle. Okay, so finding distance on a coordinate plane. So let's say this is your house, and this is your friend Emily's house. So to get from your house to Emily's house, if you live in the city, you're probably going to have to go down 4 blocks this way and go up 5 blocks that way, 9 blocks total, right? But let's say you're a country boy or girl, kind of like I live out in the middle of nowhere, and you can go and cut straight, maybe straight across the field. Maybe there's like a trail through the woods, somewhere that you can go to get from your house to Emily's house, and you don't have to go all the way around. All right, so how far would that be? Maybe how much would you save? This would be a typical ISAT Park question. How much would you save by cutting straight across the field rather than going all the way around? All right, so using Pythagorean theorem, this leg and this leg, they are the ones touching the right angle. So 4 squared plus 5 squared, 16 plus 25 is 41. Square root of 41 gives us approximately 6.4 miles. That's what that is. All right, that's the hypotenuse. So how much would you save? Well, 9 minus 6.4, 2.6 miles, 2.6 units, whatever you want to call it. So that's a typical use for the Pythagorean theorem when you talk about distance. So using that, let's try A here on the bottom of the page. Why don't you pause that, try it, and then we will talk about the formula. Okay, so we've got 1, 3, and we've got -2, 4. Now, again, let me point this out before we go on further with this one. This example that's up here, you cannot count 1, 2, 3, 4, 5, and you cannot just count like that wouldn't be a unit, because we know that diagonal, the hypotenuse, is longer than either one of those sides anyway. So my point is, you cannot cut through some boxes and just count how many ever boxes it cuts through as what that is. You actually have to use Pythagorean theorem. So now that I just erased my points, let's try this again. 1, 3, and -2, 4. All right, we're talking about this triangle right here. Here's my right angle, which means this has to be a leg that's 1 unit tall. This has to be a leg, which is 1, 2, 3 units long. So I've got 1 squared plus 3 squared equals c squared. So that's 1 plus 9, so 10. And I have to take the square root of both sides, so c is the square root of 10. Now, square root of 10 as a distance doesn't really mean much, so you might need to actually take the square root of 10. 3.16, so to the nearest tenth, 3.2 units. 3.2 units. Okay, so with that, let's talk about a formula. Now let's see if we can, well, you'll see the formula here in just a second. And it's going to look crazy, intimidating, long, scary, whatever adjective you want to use for it. But it's not that bad, especially once we talk about what these are. All right, so the distance formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, that looks crazy. You're like, what? What are all those numbers and letters? What is that? Well, let's look at it part at a time. x2 minus x1. x2 minus x1. So they are subtracting the x's. Why? because they are wanting to get how long that is right there. If your dot was here and here, couldn't I subtract those, right? Without being on a grid. If I didn't have a grid, I could just subtract 3 minus a minus 2 and get 1, 2, 3, 4, 5. That would be 5 long. All right? So y2 minus y1. y2 minus y1. They're wanting to get how long the other leg is. Again, if we didn't have a grid to count them, I could say 3 minus 0. That means this leg right here is 1, 2, 3 long if I didn't have the grid to count the boxes. That's what that's doing. Now, Pythagorean theorem. Don't you take a squared plus b squared? So if this right here actually gives you a, and this right here actually gives you b, plus is in the formula. Squaring each of these is actually in the formula. Now, doesn't that look exactly like Pythagorean theorem anyway? A squared plus b squared equals what? C squared. So the distance would actually be like d squared, but you'd have to take the square root, which that's where the square root comes in at. All right, that's where all that comes in at. It is the exact same thing as the Pythagorean theorem, only they're saying, what if you didn't want to make a triangle? What if you don't like messing with grid paper? What if you just despise triangles? Then it's given you a formula if you can memorize it. And maybe some of you are really good formula memorizers, if that's even a word. Well, it's going to be in here. So if you would prefer plugging numbers into a formula, this is tailor-made for you. So let's show you that with the example that we just did. Remember, we had the square root of 10, which was 3.2 units. Let's use the formula and show you that it's exactly the same. So x2 minus x1. Let's look here. We had 1, 3, and negative 2, 4. All right? So if we have x2 minus x1, x2, negative 2, minus x1, which is 1, squared, plus y2 minus y1. x2 minus x1, oops, I have the wrong number in there, don't I? Let's try that one again. y2, which is 4, minus y1. Yep, x2 minus x1, that's this. y2 minus y1. There we go. Squared. And I'm going to take the square root of it. I basically just plugged in all of my information into that formula right there. x2 minus x1, my two x's, squared, plus y2 minus y1, subtracting my two y's. All right, so I've got the square root of negative 2 minus 1. They're both negative, so that would be negative 3, and that's still squared, plus 4 minus 3, 1, squared. So negative 3 squared is 9. 1 squared is 1. So this is still the square root of 10, which we found out last time to be approximately 3.2 units. So using Pythagorean theorem, using the distance formula, either way will get you that answer. Again, just depends on which one you're more comfortable with. Some of you would rather use the grid, perfectly fine. Some of you would rather just use the distance formula, especially since you can use your notes anyway. Okay? So we've just talked about how the distance formula relates to Pythagorean theorem and why we do x2 minus x1 just to try and get the length of a side. And then y2 would be going up and down, y2 minus y1, square it. So example 2 actually gives you an example where they show you method 1, method 2. Method 1 is Pythagorean theorem, so they have plotted the points for Annapolis and West Point. They have plotted those points, made a right triangle, and used Pythagorean theorem. They squared the legs, added them together, took the square root, and got approximately 4.6 miles. Or if you don't want to mess with the grid at all, these are your first x and y coordinates, second x and y coordinates. So x2 minus x1, x2 minus x1, plus y2 minus y1. Square them. you come out with 9 plus 12.25. Again, square root of 21.25, which is exactly what you did here, and got an answer of approximately 4.6 units. 4.6 units. So, and it says right here, each map unit equals 45 miles. So what does that mean? That means you're going to take your 4.6 units, and if each one of these is 45 miles, you're going to take 4.6 times 45. So it's about 207 miles. So don't just give me an answer of 45 miles. It's 4.6 units. Make sure you read all the way through. 4.6 units times 45 miles per unit gives you a total of 207 miles. That would be your answer. All right, let's try another one down here. So I want you to pause and try B, please. Okay, Cromwell Field is located at 2.5, 3.5, and Dado Field at 1.5, 4.5 on a map. Each map unit is 0.1 or 1/10 of a mile long. So this is a key part. Do not forget to use this. Why it always does that? Looks like I'm crossing it out, but I promise I'm not. 0.1 miles. So let's find out how many miles it is. Or sorry, how many units it is. So let's use, since we have worked with Pythagorean theorem before, let's try one using the distance formula. So x2 minus x1. 1.5 x2 minus x1, which is 2.5. Squared plus y2, 4.5, minus 3.5, squared, and it is the square root of all of this. So 1.5 minus 2.5 will give us a -1. That worked out nice and even. 4.5 minus 3.5 would be a +1. And again, we're taking the square root of all that. So -1 squared is 1. 1 squared is obviously 1. So I'm talking about the square root of 2. So on my calculator, if I take the square root of 2, I get 1.414214. So that is approximately, using my little squiggly equal sign, that is approximately 1.4 units. But now 1.4 is not my answer. It's 1.4 units, but each unit is 0.1 of a mile. So I'm going to take 1.4 times 0.1, 1.4 times 0.1, 1.4 times 0.1, and get 0.14, and those would be miles. 0.14 miles. Okay. So I believe we got one more example for you, and then you will be done. Use the distance formula to find the distance between point X, which is 5, -4, and Y, which is -3, -2, round to the nearest tenth if necessary. So we've got x2 minus x1, -3 minus 5, be -8, which they squared to get 64. And then you've got y2 minus y1. This might be the part that gets people, but remember, like when we do slope, if it's this minus and it's already a negative, it would be -2 minus a -4. Minus minus would make that turn to a plus. So -2 plus 4 would be 2, squared is 4. So we've got the square root of 64 plus 4, which is the square root of 68. Square root of 68 is approximately 8.2. So the distance is about 8.2 units. If it doesn't tell you that each of these units is worth so many miles, don't worry about it. Just use what it tells you to do. Okay, so hopefully with that you're good. You may pick either method. Remember, we just showed you one where, actually I've shown you a couple, that we've done it both ways. Let me try that one more time. Pythagorean theorem, or using the distance formula, whichever is your preferred method of choice, that's the way I would do it. All right? Have any questions? Let me know. Good luck.